Welcome back. This is Teresa Adams with the Community College of Denver. And today what we're going to be working on is verifying trigonomic identities. So when you're working to verify the trigonomic identities, you can only work on one side of the equation. And you usually want to pick the more complicated side because it gives you more to work with. However, you do want to keep in mind your other side of the equation that you're not going to touch is the goal. That's where you want to be. So when you start to verify your trigonomic identities, frequently by turning it in terms of sine and cosine, it will simplify much quicker. It's not always true, but most of the time it is. The next thing you want to do is if you have rational expressions on one side, and so in other words you have fractions with your trig functions, you want to make it into a single common denominator, lowest common denominator, so multiply by whatever's missing to put it all over the single common denominator so you can work with just a single fraction. Sometimes that works. Sometimes, however, you might get a single fraction, and if you convert it into more than one fraction, sometimes that helps reduce. So you'll take them and turn them into more than one rational expression. And then lastly, don't forget, factoring is your friend, and so is the Pythagorean identity. These will help you simplify. So let's take a look at our first one. We're going to prove the following equation as an identity. So we're going to do our first prove this identity. I'm going to choose to work on the left-hand side. And my preference is when you are working on one side or the other, it's in your best interest to declare it. So I'm going to declare it left-hand side, LHS. I'm going to work with the left-hand side. So I've got the sine of x, cotangent of x. Well, we know the sine of x isn't going to do much. However, if I turn the cotangent of x in terms of sine and cosine, it will be the cosine of x over the sine of x. And remember, this is a multiplication there. So you can see that the sine of x here will cancel with the cosine of x here, the sine of x here. So your two sine of x's will cancel, and you are left with the cosine of x, which is the right-hand side. You have now first proved your trig identity.